you can see a screen there, a terminal view basically. Let me also log in with my credentials. Okay, so you will be redirected to a operator dashboard here. Are we on the same page? Okay. So this online simulator lab is brought to you by Armor Innovate, which is powered by Black Layer Labs. And this labs give you a hands-on exposure on how these attacks are done. Okay. And in order to understand these attacks, we have to have hands-on experience to these PLCs, machines, and these terminal emulators. So we have combined all that. We have isolated all the machines and we are running it virtually. So in the backend, there's a server which is doing the job for you, and you can see the visual representation on your screen. So it's more like you're remotely controlling a surface. Okay. So it says, welcome to the Black Layer Labs training dashboard, and your username might be available there. Okay. And before we start, let me tell you that this lab is exclusively only for today, and this won't be available for tomorrow. So after 12 o'clock, this server will automatically turn off all the authentication CSV files. So please try to generate your certificate by today itself. Okay. And there are few commands you can test. You can type labs to see the available labs. There are a total of 4 labs. One is ICS Recon, and then there is a Stuxnet lab. Then there is a Havex lab, and we have a final exam there. Okay. It is also a lab, but this the final lab is not connected to any real world incident. So which is why it's just written as final exam. Okay. And you can type launch and your specific lab ID to begin. Okay. So let's once you have completed all the labs, you will be instructed how you can download your certificate from here as well. Okay. So for now, I want you to launch the first lab, ICS Recon. Okay. This is your lab. Enter. It takes you inside a lab which is for ICS network recognition and malware analysis. Okay. Please, anyone, if you can brief us, like anyone from the panel, if you can brief us what you see and what you understand with this interface, that will be good. There are a few tabs, for example, objective, toolkit, and then there is a map that defines workstations and 2 unidentified IP addresses. Okay, so please try to understand this and tell me what do you understand by, what are you able to understand by this state now? Okay, at the state your workstation is, at the state this map is, how it looks like. Please let me know what do you understand by this. Anyone?
So there is a workstation
Yeah, there's a
and it has a firewall connected to it. And there are
yeah.
two other devices. There is a question mark. It means that if these two stations, whatever traffic they send, data, the firewall will filter it. And if
Yeah.
there is a malware, the firewall will detect it.
Yeah. So you can this is about the map. Okay, so there are two different workstations. Like there is one workstation and two different unidentified device in your network, which is 192.168.1.75 respectively, and there is 192.168.1.50, and it's your host workstation where you are having access. This is 192.168.0.10. Okay, now it it has a screen that states we are having these objectives to complete. Okay, so there are a few objectives. Let me read it out for you guys. This objective one is map the OT network segment. Lab page is not loading. Is your screen not visible or it's not loading for you? And please let me know if all of you are facing this issue. And if there is only one user facing this issue, I would recommend them to get to a stable internet connection, because that might be a problem. Command not working. Which command is not working? One second. Lab page is not working, command not working. Which command is not working? Please confirm. Launch ICS underscore recon. Why is it not working? I think you are not typing the exact command. See, I think you guys are doing a mistake here. Okay. When you are at this screen, you are supposed to type launch space the launch ID. You don't have to add these square brackets. Okay. Just the launch ID. So for me, it's ICS. Don't add square brackets there. Okay. And with that done, I think you will be able to have it working. Done? Now what we have to do is you can go to your toolkit, and there are few commands that are already written. Okay, this is to for you guys to help with the procedures. Okay, and there is a command for nmap. It says nmap 192.168.1.0/24, and this command will map your entire OT network. Okay. And then after that, you'll need to capture and intercept the network traffic. But can you explain me this nmap command? Can anyone explain me?
It's basically searching for open ports in that network.
It scans the 1.0 subnet to find all available devices and the services running on them.
Okay. So yeah, your nmap command is scanning all the hosts, and what it actually does is it sends ARP packets to your hosts. Yeah, so it will tell you what hardware devices are available in your network. So as you can see, all these devices 192.168.75 is having question. This device is not identified. And then there is another device 192.168.1.50. Even this device is not identified. So this Nmap scan is sending ARP packets to all the hosts and identifying these packets. Okay. Can anyone tell me what do you understand by ARP packet?
It's basically address resolution packet. So you just find the type of services or name of the system, basically.
Yeah, exactly. So for a better understanding, I will tell you, like, for those who are finding it difficult to understand, these ARP packets are uh, address resolution protocols. So what it does is, let's say we have a network. Okay. For example, if we take our meeting screen, okay. So I am the Nmap workstation. I will send ARP packets to all the devices, broadcast ARP devices to all the ARP packets to all the devices inside my network, and I'll say who is having this specific IP address, and whoever is will be having, they will say, I will ask who is having 192.168.1.75. So the device will say, hey, I'm having this IP address, and I will return with my MAC ID, with my specific MAC ID. And this MAC ID will be looked up inside your Nmap's vendor lookup database. So Nmap is having a vendor database. Okay. Or if you want, you can, and this database is open source. You can go to Mac vendor lookup here. Okay. And you can add the MAC address of your device. You can go to your system properties. You can quickly check. You can add your network, go to system properties, network interface, and add your MAC address, and see if it recognizes your device. Okay, so it is having a offline database that recognizes devices by their MAC ID. So when I say that I'm having the specific IP address, okay, when I'm saying that I'm having 192.168.1.75, I will return with, hey, I'm having this and this is my MAC address. Okay. And Nmap will scan for MAC address and will say, oh, okay, this is a Samsung TV. So I will recognize this device as Samsung TV. Okay. And then there's another device that will say that I'm having this. Oh, this is a Xiaomi camera, because the MAC address says Xiaomi communication, and it's a camera's MAC address. So it will return with the same device ID. So this is how Nmap identifies these devices. Okay. So you can, if you want, you can go to this Mac vendor lookup and you can type your MAC address and you can see if it returns your MAC ID. Okay. It has APIs so that if you are a application developer or if you're a tool developer, you can use this API and incorporate Mac vendor lookup in your application. So I made a port pilot kind of application back then when I was doing my bachelor's in cybersecurity. And it was giving you it used to give a command, it was turning the command line interface to a web application, and you can use Nmap from your web application there. Okay. So you can use these open source APIs and make applications. So the Nmap command here, coming to the toolkit, Nmap command here scans the entire subnet to find all active devices and their open services, providing the initial layout of the network. Okay. So once we take this command and type it on the terminal, Nmap 192.168.1.0/. 24. Okay. So after Nmap scanning is done, the scan reveals two active hosts, a Siemens S7 PLC, port 502, a Modbus device, and then it gives you a Windows 10 IoT, which is having port 8080 HTTP, which is recognized as HMI. Okay. So how do we know that it's a PLC? Because it is communicating at port number 502 and it's having a Modbus communication. And how do we know it's a HMI device? Because it's using HTTP port 80 and it's a IoT device. So we can declare that this is our HMI and this is our PLC. Okay. Or in general, you will have Intel Corporation, you'll get the name Intel Corporation and the manufacturers Siemens or Visnet W5500, the specific vendor ID. So with this, now we can say that we have a workstation in the map, which is having a HMI and a PLC. So from this stage, what do you guys understand? Please someone come up and explain so that I am satisfied and I can move to the next step.
Sir, we identify our host targets actually.
Okay.
IP.
You as an attacker can see a HMI and PLC inside the network, right?
Yes, sir.
So this we understand that the network was not segregated and from our targeted machine, we were able to scan for the HMI and PLC, right? So
Yes, sir.
yeah, so if we go to our objective section, our first part is done, which is mapping the OT network segment. Now the second part is capture and inspect the network traffic. Okay, because I think we might be needing a few more minutes because uh, there was more time used making sure everyone is having access. So I hope it's not a problem. Hello?
Yes, sir, no problem.
Yeah, it's not a problem, right? Okay.
So
So
I have a question. So you typed 192.168.1.8/24. So, but when I typed, it is telling it is an unrecognized state.
okay. So I did not type 192.168.8.24. It is 192.168.0/24.
1.0/.
Okay. So what this does is this is the subnet. Okay. 192.168.1.0 is your subnet /24 host. So it will scan for all the hosts present in the specific subnet. Okay. And I think I hope this is clear. And now we are going to capture and inspect the network traffic because now that I'm inside the network and I want to attack this network. But our first phase is to recognize what is being happening in the network. Okay. So our next step would be inspect the network traffic. And for that, we'll be using this well-known tool, which is called Wireshark. I hope you're familiar with Wireshark here. Okay. Yeah. So if there's anyone who is not familiar with Wireshark, I can just give you a quick recap what Wireshark does. So since everyone says yes, I can go with the command. Okay, we type Wireshark here, and then I and Ethernet 0. Okay, so using Wireshark, we capture and analyze network traffic to understand how the discovered devices communicate in between. Okay, confirming their roles by observing industrial protocols like Modbus or S7 communication. Okay, so once I check for this Ethernet interface and I inspect the Wireshark traffic, I can see that the capture confirms Modbus and S7 communication traffic between the devices. And this is typically used for Siemens PLC environment. So with this, previously we didn't know that we are having a Siemens PLC connected, but now that we can read the traffic, we can rectify that S7 communication is here being done. Okay, S7 here, and it's a Modbus communication. So now we can determine that we are having Siemens PLC in the network. Okay, because this is a part of your recognizing the potential assets inside your network. So you should be aware of what is the are the OEMs of the devices present in your network, so that you can capture their data sheets and design malware accordingly. Okay. So after that, what are we asked in the objectives? Yeah, exactly. This is the initial phase. Yeah. So two objectives are done. Now we are asked to perform static analysis on the sample file. Static analysis example examines the updated.exe file. Okay. So there is a updated.exe file. So it analyzes and examines this file without running it, and it PS Studio helps identify the suspicious characteristics such as functions, imports, and embedded strings. So, which can indicate malicious intent. Okay, so now we are analyzing this. Okay, we are doing starting analysis. So we will type this command. It is not doing anything. It's just analyzing for malicious strings. Okay, and after this, you can go to your analysis. This showcase there are suspicious characters here. Okay, there are suspicious imports and strings pointing to Windows registry and current version run key, a strong indicator of persistence mechanism. Okay, so we are having a persistence mechanism running here. Okay, so now that we know that this is our malware, we are going to run. This is basically analyze. PS Studio is used to analyze and examine your file, and without running it, it will check for the strings and it will indicate if there is a malicious intent, or if it is trying to alter with your Windows bat files, or it is trying to alter with your registries. Okay. And once we run that command, we go to the analysis tab, and we can see that it is having suspicious characteristics. Okay. So after this, we are going to run this. We are just examining all the malwares here. Okay. So now after that, we have to run, we are going to perform behavioral. So we are going to see how the system is behaving under the circumstances. So behavioral, or we basically call it dynamic analysis, involves running the file in a monitored environment to observe its actual behavior, confirming the suspiciousness raised during the static analysis. So now we are seeing, okay, it says that it's malicious. Let's see how malicious it is. Okay. So after running this, in the analysis tab, updates with the process log showing update.exe, creating new value in our HKU software Microsoft Windows current versions. Okay, and it is setting a new value here. Okay, in the registry key, saying stating that this is a malicious file. Okay, so now we have to report our findings in order to complete this lab. So we see that there is a key persistence mechanism being used. So after performing behavioral analysis, it says report the malware's key persistence mechanism. What is where is our malware using the key persistence mechanism? This is the location. So you just simply have to copy this location. Okay, and then go to your terminal and then type report and paste this command. Okay. So to complete the lab, you must report the exact finding that confirms how the malware achieves persistence, demonstrating full understanding of the threat. Because what this thing do to your system. So now that you have found a malware that is altering with your system's registry editors, you can you have to report the findings, and after entering the lab, it says the lab is completed. Terminal confirms the report is correct and the lab is correct completed. Now, if you type labs again, you get redirected to the operator dashboard, and when you type labs again, you see one of your lab is completed. Okay. So please let me know all of you have completed their first lab. Okay. If you have completed.
Sir,
Yeah.
sir, can you explain again from where we will get the location?
Where you can get the location.
Yeah, I mean, we have to give the path, no? Report path.
Yeah. Yeah. So go to your analysis tab, and in your analysis tab, you have a location called hkcu/software/microsoft/windows/current version/run/system update. So you have to type report and type the exact location there. And with that, your lab is completed. ICS network and recognition lab. And then we can move towards our Stuxnet attack simulation. So I remember someone, uh, yeah, shows completed. Yeah, I remember someone mentioning that they are not able to comprehend the Stuxnet story when I was demonstrating, since we didn't have a graphical view of it. So this Stuxnet lab simulation, attack simulation, will show you how the attack was done. Okay, and I hope this makes concepts clear for you guys. Okay, so we are launching the Stuxnet lab now with command launch Stuxnet. Okay. Someone please explain me what you see on the screen, and please confirm that we are on the same page here, so that we make sure that everyone is in line. And within next 15 to 20 minutes, I think we'll be completing all the labs. Yeah. Please, someone please come on the mic and explain what you can see here. This is simulating your famous Stuxnet attack. Okay, I'll.
So I think there is one USB, which is the attack vector, and
Yeah.
we have the engineering workstation where the USB has to was inserted or will be inserted.
Okay.
So the attack,
Yeah.
and since we need to analyze, so I think, and one is that Siemens PLC controller is there, I think,
Yeah.
which is PS,
7315 PLC
and the
controller.
centrifuge is there,
Yeah. So
on which the attack was done, I think.
yeah, so our centrifuge is also there, which is rotating at 1000 hertz. Okay, we are having a HMI readout. Okay, which says that our centrifugal is running on 1000 hertz, and uh, its actual speed is also 1000 hertz. Okay, so all this information, just assume that this information has been already given to you by the intel agencies. Okay, this is how your Stuxnet attack was performed, and it was a very highly sophisticated piece of malware that is spread via infected USBs to bridge the air gap and to isolate the OT networks. Once it is identified, if you go to your toolkit, you can see you are given a set of commands here. Okay, and this there is a malware inside your USB initial vector, and this identifies a specific target. It is identifying Siemens step 7. Okay. If there is Siemens step 7 software on your engineering workstation, that means this is where you have to start the attack. If not, it will jump to another workstation. Okay. So firstly, we are going to analyze the infected USB to gain initial access. So go to your command line interface, and we have a very basic command. Okay. Analyze F column slash, and if you want, you can copy it from your toolkit as well. Okay. Second, I think. Okay. So after this, we get a result. Okay. If you look at this result here, this analysis has revealed that there is a malicious.lnk file that exploits a vulnerability CVE 210-2568 to gain initial execution on the host machine. Okay. So after determining this, now we have to propagate to the engineering workstation. Okay. So in order to, from this host, the attacker moves laterally across the network by exploring a known vulnerability. And our known vulnerability is MS08067. Okay. This is our command, exploit.
Sir, is it only a name MS08-067? That's something else.
Yeah, so MS08-067 is a vulnerability that is being searched across the network here. Okay.
Okay.
Searching for this vulnerability across the network. So we'll type the network as well. So this is our engineering workstation. So in this specific workstation for the specific host, we are typing, the same searching for the same vulnerability will be done for each and every devices. But with respect to this engineering workstation, this is programmed. Like this workstation is already deployed with Siemens Step 7 software. So we just have to find this Siemens Step 7 software here. So we are scanning this specific workstation, which is 10.10.10.20. Okay. After doing this, the result
Sir,
succeeds. Yeah.
sir, how we got this vulnerability?
How did we find this vulnerability?
Yes, sir.
We are finding this vulnerability throughout all the systems. Okay. And this system happened to be one with this specific vulnerability. Okay.
Name,
Which is,
name, sir.
yeah.
Name,
Sorry, mail.
name, sir. Name.
Name of the vulnerability. Yeah. So name
Yes, sir.
vulnerability is MS08067.
Okay, sir.
This is searching for the specific vulnerability throughout the workstations. Okay. And until and unless this specific vulnerability is not found, it won't get to the next step. Okay. It is a Microsoft vulnerability. If you want, you can, get in detail analysis of this vulnerability. It's a Microsoft security built-in vulnerability. It's a server service cloud vulnerability. Okay. So once this is exploited, it says the exploit succeeded, and it's granting the attacker a remote shell on AWS. See, it says successfully moved to AWS. That means now we have access to the engineering workstation. Okay. So our second objective is completed as well. And our third objective is identifying Siemens S7 software on the engineering workstation. Okay. Till here, I guess everything is clear. Now with the command find step 7, malware is highly targeted, and this command is searching for Siemens step 7 software. So there's a find script. Okay. And the terminal confirms the presence of step 7 software, validating the target. Now that we know, capable of edit or reuse means we are, yeah, exactly. We are capable to edit and we can reuse it. Okay. So now that the terminal has confirmed us, okay, if you look at the terminal here, okay, target is confirmed. Okay, this is a part of this find script was a part of the malware. Okay, so now that my find script has confirmed that the target is capable of injecting the payload into the PLC. Now we are injecting the payload structs.dll file inside the PLC. Okay. So our target is validated. Is it clear for you guys till here?
So,
Now,
sir,
yeah.
why it is step 7? Is it fixed? Step 7 is fixed. That word keyword.
What?
That keyword find step 7. Is it
Yeah.
fixed? Step 7 is fixed.
Yes.
Or is it a name of a file?
Step 7 is name of the software.
Okay.
Step 7 is name of your software, which is used to control PLCs, Sematics, specifically Sematics S7, Step 7 PLCs. So we are searching for Step 7 software inside this workstation. If it is having Step 7 software, that means this workstation is capable of communicating with the PLCs, which is having access to the centrifuge. Okay.
Fine,
Just
sir.
one more
Fine.
thing, why we are showing H7. H7 is H7com basically, the protocol which Siemens product use to communicate. Okay, for the communication channel, they use H7com protocol. Okay.
Fine. Thanks.
Yeah. So I hope this is clear for you guys. Now we have access to the engineering workstation. We have confirmed our target, and now we are going to inject the payload, which is structs.dll inside the PLC. Okay. So there is a PLC in underscore inject script, and if we provide it the payload, it will inject the structs.dll. So this malware is more of a framework. Okay, so we just get this PLC inject payload command, and once we enter this command with control to the engineering workstation, the attacker can now communicate with the program and connected PLC. Okay, and this command injects the malicious payload directly inside the PLC's EPROM memory. Remember, I have told you the entire anatomy of PLC, where MCU is located, where the EPROM is located. So this injects the payload inside the EPROM memory directly. Okay. After doing this, you can see your map S7315 PLC on your map is green. That means you have access to your to the PLC as well. So the result of this command would be PLC is compromised and malware begins replaying normal sensor values to the HMI. So once we inject the PLC, from the time we inject the PLC, now all the HMI values are having fake values. Okay. So replaying normal values to HMI. So normal 1000 hertz value will be replayed to HMI again and again, where the sensor output should be given. So now we can fidget with the actual speed. Okay. So there is a command to set the frequency value to 1410 hertz. Okay. So this is the final stage of attack to sabotage. But normally in Stuxnet, it took almost around 2 years, but we have to complete it today itself. So yeah, this command instructs the customized PLC to alter centrifuge's speed from normally 1000 hertz to 1410 hertz, indicating successful sabotage. Okay, so we are changing the frequency values here. Okay, we are doing it manually, but the malware was instructed to do do it remotely without any human interaction. Okay, so after this, you can see your centrifuge is into over frequency. Actual speed is 1410 hertz, but the HMI readout is still 1000 hertz. Okay, so with this, we exploit our malware. And now, if we go to our objectives tab, all the checklists have been done, but one last final, it says report the final sabotage command. Okay, so you go back to your terminal, and now you have to report your final command. So this was your final sabotage command. Set frequency. Take that command. Set frequency value to 1410 hertz and report this in your terminal. And with this, your lab is completed. If you have any doubts in the Stuxnet lab, please let me know, or we can proceed with other labs as well. So with this, 2 of your labs have been completed. And after this, we have a Havix lab. It's a Havix malware lab. Okay. Are we done with the Stuxnet? This is going to be the last part. So please confirm
Yes,
if
yes. Done,
yeah.
sir.
Okay. No.
Yes, sir. Done.
Yeah. So yeah, done with Stuxnet. Now we are going to launch a Havix lab. Okay. So let's understand the scenario here. The Havix campaign used a watering hole attack. Sir, report finding is not working. Lakshmikant ji, you have to just report the final command. You just have to report, have to type report space set underscore frequency space columns, double columns, values space 1410 hertz. The last command that you had on your toolkit. Yes, exactly. Please confirm once you have done that. So yeah, so this is a watering hole attack, compromising the websites of your industrial control systems, and specifically the software vendors. So when engineers download a software, they received a Trojan version that installed the Havix RAT, remote access Trojan file. Okay, and the RAT is connected to a C2 server from which attackers deployed modules to scan the OT network for OPC servers. So by querying the servers, attackers should map the industrial process without altering PLC level security. Okay, so let's understand the toolkit first. it says run setup.exe. Okay. And our first objective is to gain initial access via Trojan vendor software. Okay. So we are going to execute a legitimate installer. So let's understand that I myself am a guy working inside the company, and I am installing this software from the vendor's side. So let's say I'm planning to install Siemens S7 altering software, or I'm installing an Open PLC editor to program my PLCs. So after installing the software, I will run the setup.exe. Okay. So I'm normally running the setup.exe, thinking that my software will be installed, but the main server is infected with uh, Trojan rats. So it comes with a virus along with that. So I'm going to run setup.exe. Okay. Is this clear to everyone? Now my setup.exe was having a hidden payload msx.dll, and it's a Havex rat malware dropped into the temp folder. Process injected, initial branch successful, rat deployed. Okay, so this is visible to me because I'm the attacker, but for the workstation guy, he has just installed his software, but by installing his software, he has given me access to his workstation. Okay, is it clear? Now, with our first command, Havix rat is secretly installed on the workstation, establish initial breach. Okay. And now I'm going to communicate with the device. So now we are going to connect with C2. Okay. It says establish and control the communication. Okay. Establish command and control the communication. So the installed rat must phone home to the attacker server to receive commands, and it should exfiltrate data. So this command initiates the C2 connection. Okay, so let's try to connect with C2. Okay, and once we type this command, a successful connection is established, and it is giving access to the workstation from the vendor side. Okay, and now we are going to scan the OT network using the OPC protocol. Okay, so me as an attacker, I'm using a specialized module to scan the network for OPC servers and a common data exchange hub in OT environments to gather intelligence passively. So in order to do that, let's go to our toolkit, and this is a simple command called scan OPC. We're using this command. Okay, so let's see. There are OPC servers discovered. Okay, so there is one OPC server discovered, and in the analysis tab, you can see the OPC tags: motor.rpm, value.status, and pressure.psi, revealing the key data points about the industrial process. So now we know the key data points of the industrial process. After scanning, now we are going to do an in-depth search, and we are going to deepen the access. We are going to deploy a secondary payload. Okay, and we call this payload as we are going to deploy our Karagani to steal the credentials. So let's deploy our Karagani payload. Go to the toolkit. this is my payload. So once the payload is deployed, you can see the terminal indicates successful credentials harvesting. Okay. So now that we have the credentials, we can exfiltrate the gathered in intelligence. So this is going to be our final step. We will package all the collected data, network maps, OPC data, and credentials and send it back to the C2 server. Okay. So in order to do that, in order to exfiltrate the gathered intelligence, we just have to run a script called exfiltrate, which is inside the machine already. Okay, so now the data is compressed into OPC data.zip and it is successfully sent to the attacker. So now attacker can have this data without even typing a single command inside the user's command line, because all like the victim has only downloaded the file, and after installing the file all these commands have already been executed in a step-by-step approach, and after this all your file findings is gathered inside the opc data.zip and it is sent. Okay, so now that attacker is having the file and it is being exfiltrated. Now we are going to report the key exfiltrated data file. Okay, it says report the key exfiltrated data file. So reporting, we have to report OPC underscore data underscore ZI dot zip. Okay, so you have to report your OPC data file, and once you have reported, the lab is completed, and it has the name of the file that is stolen. It's always in zip compressed. Yeah, it is always in zip compressed format, because there is no altering in the information when it is compressed into zip formats, and there is no problem compressing these files using our command line interface, because you having uh, a visual access to your screen, you can see if there is anything malicious running inside your system. But with this, like it is very easy to patch all these data inside a zip file. So using command line interface. So always it is the havexrat file always compresses the important data into zip file and sends it to the C2 server. And once you enter this command, your lab is completed. And now you know how a Havx remote access Trojan files executes its set of malwares, and it takes important data of your plant. Which is why downloading softwares and authenticating the downloads is very important before installing them. Okay. If the victim would have had scanned the setup file before installing, and if we wouldn't have assumed that, oh, it is the Siemens server, so I don't think there should be a problem. But since the attacker have infected their servers, so whoever is downloading the software from their server are infected as well. Okay, and zip are compressed, so you can any day open and see, oh, how many systems have we acquired, and you can see your remote Trojan horses inside all those systems, and you can strip the malware in such a way that this remote Trojan horse can self-destruct after sending the acknowledgement to the C2 server. Okay. But people, they don't usually do that. The rat, mostly your rat malwares are still inside the system. So that with this, if attacker wants to perform a ransomware as well, they can always come back with the backdoor. Okay. So with this, we complete all the 3 labs. Now we are having our final examination. It is going to be a coordinated attack scenario. Okay. And I want you guys to try this yourself. Okay. But yeah, we are going to launch it. So try this yourself with help of toolkits, and I think it will be easy for you guys to understand. And if you want me to explain this lab, just let me know. You can see the visual attack plan. Done certificate. Oh wow. So I think most of you have already generated the certificates. Okay. So still let's understand the vector here.
If possible, can you explain that?
Yeah. Okay. So here we are having IT zone. Okay. It represents a modern attack path. Okay. It's not Howard's attack path or a Stuxnet attack path. Attacker first compromises the less secure IT network. Example, public website. Yeah. Once you have completed the lab, you can download the certificate by typing certificate on the terminal. Okay. Yeah. So attackers, they first compromise the less secure server. Okay. So it's the public website. So exploit public web server vulnerability. Okay. It says public web server vulnerability. And from there, they pivot into the more secure OT network. Okay. So first, this is the initial gain. And once inside, they will identify the target PLC. But instead of just sending malicious command, they will first disable the operator's view by replaying normal data to the HMI. And with operator behind, can safely send commands to PLC to shut down the process before erasing the logs. So once I am inside your OT network, I will send you the false values saying showing your HMI that hey, your plant is still active. Please describe success shell gain on web server 1. Yeah, I'm going to explain you this lab. So I hope I will be clear. Okay, so now once I'm inside the network, I will send the fake values to the host saying that your HMI is still on, but I will turn off your plant and I will erase all the system logs so that you will never understand that there was an attack. Okay, so first let's exploit the public web server here. Okay, so it starts with a network parameter. Let's go and see the command. It says exploit CEV dash please report what. Yeah, we are doing it now. Please follow. CEV dash 2017 dash 5638, and it's the server IP address 203.0.113.10. Okay, so it uses a known vulnerability. It's a Apache struts vulnerability. If you take this vulnerability and check, it is a server side vulnerability. Okay, and it's a Apache server vulnerability. It's called Apache struts vulnerability. Okay, so it takes this vulnerability and exploits it on the specific server. Okay, so let's exploit this vulnerability first and see what is happening with the station. So once the exploit is successful, it gives the attacker a shell on public facing web view. Okay, so it says found Apache status 2, and yeah, I will tell you what command you have to report. Once let's try to understand what is happening here first. Okay, And now we are having initial access on the web server as it turned green. Okay. Now it says pivot from IT to the OT network. So since this company had a segregated IT network and it is having a firewall between IT and OT network, we have to pivot from the IT to OT network. Okay. So the compromised server has it has multiple network interfaces. The server is having multiple network interfaces. So let's see the command. It says pivot iface Ethernet 1. Okay. So this command uses the internal Ethernet 1 interface to cross the network boundary from IT zone to the OT zone. Okay. And once we type this command inside the terminal, we have access to the engineering workstation as well, because it has pivoted from one interface to another interface. It has come in, it came to the OT network boundary from the IT network boundary. Apache has its own hardware credentials, but sometimes your Apache server has the default credentials set up. So yeah. Now we have to.
So this one very. So
Yeah.
in this case, we should know the physical deployment of the structure. We should know that
Yeah,
each
exactly.
one is connected to the OT network only.
Yeah, see, you have to understand, once you see the vector here, the screen here, if the screen is already having internet, web server, firewall, engineering workstation, HMI, and PLC, this means that you have already done the recognition part. Okay, and you know the entire map, and now you're gaining access. So you were physically available, or you have the network plan. Now you're just gaining access. Okay. Am I clear?
Yes, sir.
Yeah. Okay. So now we have to identify primary process controller PLC. So for that, we have an nmap command. Okay. So attacker has to scan the OT network, specifically this port, 44818 port. Okay. Because it is used by Ethernet IT to quickly locate Rockwell and Allen Bradley PLCs. So it is having we have to check for these ports to check to see if there is a Rockwell PLC connected. So yeah, now we can see that it is having Rockwell PLC connected. Okay. So now that we have access to the PLC, now we are going to manipulate the PLC in order to blind the human to machine interface. Yes, but it only halt, no permanent solution. Yeah. Uh, see, it is a never ending process. You have to understand. Yeah. So this can identifies our PLC networks. Okay, now we have to manipulate. So now we have to get inside the EPROM, and we have to inject our payload. Okay, so we are going to run coordinated attack.py. Okay, this script performs a coordinated attack, and it intercepts and replays normal data to our HMI, and this will basically blind the operator while simultaneously bypassing the PLC's safety logic. So we are going to execute this Python program. Okay, it says HMI is now binded. So now with the blind HMI, we can now do whatever we want to do with the PLCs, and it will show the normal status to the HMI user, and PLC is prepared for malicious commands now. Okay. So it says cause a controlled process shutdown. Okay. So now we have to cause a controlled process shutdown. So with the operator blinded, we can use this command, shutdown PLC hyphen force. So this command basically it's sent to PLC to force the industrial process to halt. Okay. Now our terminal confirms the shutdown command was sent to the PLC, and PLC is now at halt. Okay. Now what we are going to do is we are going to make sure that there are no footprints. So we will erase all the log files. So this is very crucial step to understand that how to clear your traces after the attack. So we take this command, we put it on the terminal. This deletes the logs and it compromises the system to handle the forensic investigation, so that if someone is doing the forensic investigation, there are no longer log files. Okay, so logs are erased. Submit your final report. So now we are supposed to submit our final report. So it says report the final shutdown command. So let's report the final shutdown command. What was our final shutdown command? Shut down underscore PLC. With this done, all our 4 labs are completed. And if you type certificate in your dashboard, you can download your certificate from here. Is that clear? How will we get the actual values? See, if this is the main reason to erase the logs. Okay, logs are supposed to be erased in order to make sure that there once the investigation is done, your malware and what has actually happened is not shown, because if that is shown, then your entire attack terminology can be reverse engineered and your malware can be seen through IDRA. Okay. Yeah, Omer, you've raised your hand. Certificate. Sir, which command after report? Is there any way to recover the logs? Yeah. So there are many ways to recover the logs. There are special softwares for you to recover your logs. Once you delete these logs, there are always the reconstruction files. So you can use forensic softwares to reconstruct those files, and you have to check for log files, .text files, and other temporary files while performing the forensics. So yeah, you have to reconstruct the file. Yeah, report shutdown PLC. Yeah, shutdown PLC, not shutdown PLC. Basically, you have to report shut down underscore PLC force. I've sent the command. Okay. Please let me know if all of you have downloaded the certificates. And if anyone is facing any issue with the lab, just let me know. Okay, you're stuck at the report section. Look on what is the problem? What is happening there? Can you please share your screen? Yeah. So you Rocky Kumar has asked where can I use the certificate. So this is a certificate stating that you have completed the simulations for all these 4 labs, and you can this will certify you saying that you have a practical exposure to Stuxnet attack simulation, Havoc's rat simulation, and ICS network analysis lab simulation. Incorrect. Report the exact final command. So please, can you please share your screen so that we can see what is happening there? Lakshmikant? Okay. Type report. Type report space shutdown underscore PLC. Underscore PLC space force. Yeah, completed. Now you type certificate to download the certificate. Okay, so yeah, with this we come to an end of the session. And if you have any questions regarding the labs or any reviews, you can share your reviews here. Yeah, Vikasji, you can take over from here. Quiz timing and where is the quiz link? That will be shared to you by the organizing committee, I guess.
Yes. Thank you so much, Sushant sir.
Yeah.
And I hope participants have really enjoyed this session. Okay, so I think quiz, we will be uploading that on the canvas. You will be able to access it from there. We will announce it in the group. Don't worry for that one. Okay, so there are certain attendance criteria also. Those who are falling below that criteria, they might not be able to get the certificate right now, but they will have to complete it from YouTube. Then only they will get to know. They will get the
For those who are having the
anyway. Moving ahead, already we are moving late. So this was the final session that we were having, and ultimately we can, at the end of the session, definitely the kind of session we had was very much insightful, and we can say it was very explorative in nature. So definitely many of the thing was covered here, and I hope you all have enjoyed this one, and that may be helpful in your own domain, wherever, whether you are teaching or having research in that particular domain. I hope it will be of useful. And with this, I will request all the participants as well as the speaker to bear with us as we are going to conclude the session. So let me just check how many of us have connected. Okay, only 40. Okay, anyway, so a very good evening to all of the participants as well as the respected speakers. On behalf of ENICT Academy, MNIT Jaipur, I extend a warm welcome to everyone present for the valedictory session of our faculty development program on malware analysis. Over the past 1 week, we have completed an intensive 40 hours journey of learning and exploration, covering foundation of malware analysis, static and dynamic analysis, advanced forensics, Android malware, and AI-driven defenses. It gives me immense pride to say that this FDP has been a collaborative success thanks to the collective enthusiasm of participants, the dedicated efforts of the organizing team, and the wisdom shared by our eminent speakers. So the amount of exposure they carried, the way they have delivered those exposure was very much, we can say, fruitful for participants. So this FDP has not only deepened our understanding of malware analysis, but also provided hands-on exposure to real-world tools and case studies like the one that we are having now. For conceptual discussions to practical demonstration, from academic perspectives to industry insights, the program was equipped and has equipped us with the knowledge and confidence to integrate these learnings into the teaching, research, and real world problem solving wherever we are basically working on. Okay, so we hope that participants will carry forward this experience to their classroom, like many of the participants were talking about laboratories and future projects, thereby multiplying the impact of these initiatives. So we, the organizing committee, also express our sincere gratitude to Professor N.P. Padi, Chairman ENICT Academy and Director MNIT Jaipur, for his visionary leadership and constant encouragement. I also express my sincere gratitude to Professor Vineet Sahula, Chief Investigator ENICT Academy, whose guidance has been invaluable in shaping this program. Our co-chief investigators, Professor Love Varga, Professor Pilli Emmanuel Subhakar, and Dr. Ravi Kumar Madilla, for their continued support and mentorship. I would also like to thank Dr. Satya Sai Jagannath Nanda, Coordinator ENICT, for his dedicated efforts in bringing together such an enriching programs. We also extend our heartfelt thanks to our eminent speakers like Professor Sandeep Kumar Sukla, Professor Somnath Tripathi, Professor Neminath Hubali, Professor Vijay Lakshmi, Professor P. Vinod, Dr. Saurabh Kumar, Dr. Pilli E. Subhakar, Dr. Mustaq Ahmad, Dr. Meenakshi Tripathi, Dr. Ramesh Babu Batula, Dr. Nitish Kumar Bharadwaj, Dr. Sweta Sharma, Dr. Jyoti Gajrani, Mr. Rohit Shukla, Mr. Abhijit Mohanta, Mr. Pankaj Upadhyay, Mr. Sushant Tiwari for this amazing sessions. Your presence and contribution have definitely made this FDP a truly memorable and impactful experience for all of us. So we are grateful to all the participants who joined us from diverse institutions across the country. Your active engagement, questions, and interaction have kept the sessions lively and meaningful. We have received highly encouraging feedback, and it gives us confidence that this FDP has fulfilled its objective of capacity building in cybersecurity education and research. And finally, on the behalf of organizing team, I take this opportunity to express our deep gratitude to our respected director, chief investigator, and co-chief investigators for their constant support, to our esteemed speakers for sharing their time, expertise, and invaluable insights, to our coordinator, Dr. Satyasai Jagannath Nanda, and most importantly, to our enthusiastic participants without whom this program would not have been possible. So thank you all for making this FDP on malware analysis a grand success. With this, we formally bring the faculty development program on malware analysis to a close. We hope that the knowledge and skills gained during these sessions will inspire new teaching practices, research contributions, and collaboration in the field of cybersecurity. So wishing you all the very best in your academic and professional journeys. Thank you once again, and we look forward to meeting you in our future programs. So have a great evening and happy learning together. So with this, I would also request all the participants to kindly provide us with feedback. You are now panelists, so if you have any feedback that you want to share right now, so definitely at the beginning, many of my colleagues told that this such kind of FDP won't work, no one will join. But the way I have seen participants interacting with the experts just amazed me. And even I talked about these sessions with my colleagues that this is happening right now. So definitely they are saying that we may go with the next version of this malware analysis. So definitely from the perspective of research, okay, we will be having some program aligned to the research part of this malware analysis. So definitely I hope to see you there also. So if you have any feedback regarding this FDP, you may unmute and have a few words for this one. Thank you all. Thank you, Sushant sir. Thank you, Pankaj sir.
Thanks for having us.
Vikasji.
Thank you so much, sir.
Anyone who wish to share any few words for this one, this FDP, feel free to share.
Hello, Vikas, am I audible?
Yeah, you're audible.
Hi, Mukul, if you want to say something, you may please.
And all the faculties who have been teaching for past 7 days, it has been a great experience, a learning journey. I am a bachelor student from Rashtra Raksha University and currently exploring this field very widely.
One?
All the sessions have been really engaged.
Thank you, ma'am. Thank you, Tejaswini, ma'am. So, if none of you are interested in providing the feedback, then also it is fine. I hope this would have been a fruitful session for all of you. Sir, Ajay sir,
Yeah.
would you want to say
Vikasji,
something?
I like to extend my gratitude to you and all the panelists, especially speakers who deliver their valuable knowledge.
So
And
your voice
although
is
I'm
not
not able to
audible.
attend all the sessions, but today I attend the whole sessions, and I personally feel like this is one of the coolest sessions I ever had. So much interaction,
Any
and
feedback that you could provide us?
that's what I say.
Thank you so much, Lakshmikant Vasishtha sir. Could you
it's one of the
provide a
coolest sessions.
constructive feedback so
Part
that
is
we
that.
can improve upon that one in our next FDP?
Am I audible, sir? Hello.
Yes, you're audible. Yes, you're audible. Yeah.
Yeah. The point is that, sir, more or
Thank you,
less, it's
Pooja
kind
ma'am.
of we take
I
project.
hope to see you in future series of this FTP. This was a success in a sense that it is not AI or deep learning kind of topic, and still we are having such a enthusiastic participants. So definitely we are going with the next round of this one. We hope to see you there also, but that will be aligned with the research only. So
Hello, good evening. This is Rajesh, sir.
and anyone else?
Thank you so.
Rajesh sir,
Hello.
you want to say something?
Sir, am I audible now? Hello?
Yeah.
Okay,
Yeah.
so
Yeah. Thank.
no, actually, I'm unable to actually hear them.
Yeah,
Why?
Ajay sir was also
Why, sir?
speaking something, and Rajesh sir is also here. Okay, you can go one by one. We are going to turn off our mics for now. Yeah, guys, you can proceed.
Hello, good evening. This is Rajesh. Thank you,
Just go ahead.
Vikas sir, and the entire EICT team for organizing this wonderful session. And we have really loved all the speakers speaking on different aspects of malware security and malware analysis. And we hope that this kind of session will be organized later in the considering the advanced stages of this malware analysis also. So I would like to join another sessions also. But a kind suggestion for this EICT organizing team, it would be great if the session will be kept short, at least for 2 to 3 hours, because making ourselves available for entirety of 5 hours, it will be difficult. I hope other sessions will be like 2 to 3 hours, so that 2 to 3 hours will be able to spare and we'll be able to focus on our other works also. Thank you.
Yes, sir. We were actually initially we thought of that one only, but actually now actually I was planning it for the summer vacation, but unfortunately I didn't get that slot. So definitely in future I will definitely consider this one.
Thank you so much, sir. Anyways, it was really informative and we enjoyed it.
Thank you so much, sir. And
Jagdeep ji, regarding the hands-on sessions, actually, if possible, we were planning to deliver PLC hardwares to you guys as well, so that you can try it on your with your computers. But in online session like this, we cannot do that, which is why we had to provide you with the virtual labs.
No, sir, it's okay with the virtual labs, not a problem. Actually, this is the last day we have doing the hand-on session only.
Yeah.
The previous days we are actually not any this kind of activity. That's why I'm giving this suggestion.
Yeah, exactly. Because previously we had the same OT security session in Defense Institute of Advanced Technologies, but that was an offline session where we took 10 PLCs and we demonstrated them how these PLCs are configured and we hack into the networks. But it is not possible with the remote structure this way, so which is why we deployed online labs for this. Okay.
No problem, sir. No problem. Thank you.
Thank you.